Welcome back, everyone. So we're going to be looking at this. So this is going to be the JMSS coordinate geometry part 2. And today we're looking at parallel and perpendicular gradients as well as simultaneous graphs and number of solutions. So let's get straight into it. Sweet. So let's talk about parallel and perpendicular gradients. So a parallel line refers to a line that shares the same gradient such that they never intersect. So for example, if we had y equals 2x and then we had y equals 2x minus 2, we can see that the line y equals 2x minus 2 is always going to be below the line y equals 2x. But because they have the same gradient and they increase at the same rate, so they have the same slope, they will never intersect. So these are what we call parallel lines. Now, if we have lines that are perpendicular, it just means that those lines intersect at 90 degrees. So we sometimes call this the normal line, but in this case, I'm just going to refer to it as the perpendicular line. So this intercepts at 90 degrees. Now, the difference between these two lines, these two special lines, is that we can see that from this rule here, for parallel lines, m1 is equal to m2. For perpendicular lines, because it intercepts at 90 degrees, we would say that m1 is equal to negative 1 over m2. What I'm trying to say from this is that if you have a pair of parallel lines, you can tell that the lines are parallel if the gradients are equal. And for perpendicular lines, you can tell that that they are perpendicular if they follow that negative inverse uh, um, relationship. And this all ties back down to the equation of a line, which is from y equals mx plus c. So let's look at an example of a question. Let's say we have the question, find the equation of the line parallel to 2x minus 3 and intercepts 110. So I've just zoomed out here. Now, to understand this question, we just have to know that any line that's parallel to 2x minus 3 would share the same gradient, since we know that parallel lines have the same gradient. So we would say that the gradient of the line we're looking for is going to be, since m1 is equal to m2, you could say that m2, which is the parallel gradient, is equal to 2, since, this is m1, and they're equal to each other. So in this case, now effectively it comes back down to what we learned last time, and it's that we have a intercept, a coordinate, and also a gradient. So we can just use the point gradient formula, y minus y1 is equal to mx minus x1, and we can say that y minus 10 is equal to 2x minus 1, which will then be y is equal to 2x minus 2 plus 10, which is just 2x plus 8. And that is how we answered that question. So I'm going to give you guys an example of a question for you guys to try, and I want you guys to give a shot at that. The question, find the equation of the line parallel to negative 2 plus x over 4 and intercepts half negative 2. I'll give you guys 1 moment to solve that now. So please pause the video. Welcome back. So we're going to be going through this question now. In this case, whenever we have something like this, we can see that this negative is underneath this bracket. So if we have, for example, negative 2 plus x over 4, that refers to the whole thing being multiplied by 4. But if we have negative 2 plus x over 4, and we can see that this negative is within the bracket, that refers to that negative 2 itself. So it's not actually the whole thing. So in this case, if we were to break this down and we were to split the fraction, it's just going to be negative 2 over 4 plus x over 4, which is the same thing as x over 4 plus, or in this case, I guess you would say minus half, which is also the same thing as saying 1 over 4 x minus half. The reason why I know it's 1 over 4x is because x over 4 is the same thing as 1 over 4 times x. So in this case, we know that since m1 is equal to m2, and m1 is 1 over 4, so that's 1 over 4, we would say m2 is equal to 1 over 4. So again, we have a point and a gradient, and we can just use the point gradient formula. So that's just going to be y minus negative 2 is equal to 1 over 4 x minus half. And that's just going to give us y is equal to x over 4, and then that'll be minus 1 over 8, because quarter multiplied by a half. and then this will be a plus 2, so when you move it over, it'll be a minus 2. And that's because y minus minus 2 gives us y plus 2. If you were to move that over, we would have to subtract it. And then just a little bit of quick maths. We now have, what's that? 17 over 8. Negative 17 over 8. And that would be the equation of that line. So now let's have a look at perpendicular lines. Let's say we have the question. I'll find the equation of the line that is perpendicular to 1 minus x over 2 and intercepts negative 16, negative 1. So now this one's a little bit different. If we were to just break down what 1 minus x over 2 actually means, and you would have split the fraction, that would just be 1 over 2 minus x over 2, which is the same thing as saying negative 1 over 2x plus half. In this case, we know that this is going to be our m1. So this is our m1. So you would say that m1 is equal to, or you can just say that m2 is equal to negative 1 over m1. And that's just to say, basically, in essence, what that does, if you want to do all the fancy math, is just to flip the fraction and make it negative. Or in this case, if it's already negative, we're making it positive. So then you would say that m2 is equal to 2, because you just flip the fraction, so half becomes 2, and then you make it negative. And in this case, if it's already negative, you just flip the sign, so it becomes positive. So that's our m2. And then from here, you would, well, now we have intercept and we have a gradient. We can say that y minus negative 1 is equal to 2x minus negative 16. And then from here, you get y is equal to 2x plus 32, because that negative makes it a positive, minus 1. So that's just 2x plus 31. Now, some of you guys might be confused about this one here, so I'm just going to explain this again. But not again, but I'm going to explain it from a more mathematical point of view. If you have m2 is equal, and what I'm referring to is the how I got 2 specifically. So negative 1 over negative half is the same thing as saying negative 1 divided by negative half, which is the same thing as saying negative 1 times negative 2. You flip the sign, that's just 2. That's just to explain it mathematically because I felt like I did it a bit pause there. I'm going to give you guys a question to try, and we'll see how you guys go. Yeah. Find the equation of the line normal to negative 2x plus y equals 1 and intercepts negative 1, 0. Now, don't be fooled. Normal just means the same thing as perpendicular. Feel free to pause the video now, and I'll check back in with you guys after you guys are done. So, let's go through the question. Find the equation of the line normal to this equals 1 and intercepts negative 1, 0. So the first thing we need to do is we need to solve for y, because we want this in the form of y equals mx plus c. Y equals mx plus c. If we were to solve for y, we would actually get 1 plus 2x. So 2 is going to be our m1. Now, if we're looking for the line that's normal, that means we're looking for the line that's perpendicular. We would say that m2 is equal to negative 1 over m1. And because of that, we realistically just flip the sign and make it negative. We know that m2 is going to be negative half. You take 2, you flip it, that's just 2 over 1, which flips becomes 1 over 2, and then you make it negative, which is negative half. Now, again, we have an intercept and we have a gradient, and we can just find the equation of the line. So we get y minus y1, which is 0, is equal to negative half x minus negative 1, which effectively is y is equal to negative x over 2 minus 1 over 2. And that's it. Congrats. So that's pretty much perpendicular and parallel lines. And then we'll get started on to our next topic. So now let's have a look at finding the intercept between two graphs, or I guess you could say simultaneous functions if you wish to call it that. But pretty much a question might ask you to find the intercept between 2x plus 3 equals y and 2x minus y equals 1. So to do this, this is just an example of very basic simultaneous equations. And to find them, we just need to realize that if we already have y, then we can just simply sub y, or whatever this is, because it's equal to y, into this equation here. So effectively, it's just knowing when and how to substitute. If you've done simultaneous equations before, then you'll know what I'm talking about. So in this case, we just take y, we pop into that y there, and that would just be 2x, that would just be taking this equation here, we get 2x minus y. But instead of y, we have this here. So 2x plus 3. So we 2x plus 3 equals 1. And this is okay to write because we know that this y, and because we're trying to find the intercept, we're trying to find when the x and the y coordinates are the same. So since the x and y coordinates are actually the same, we can assume that y in this equation, the left equation, is equal to the y in the right equation, and so as the x's. From here, we can simply solve for what x is, and this would just be 2x, remember to expand this, minus 2x minus 3 is equal to 1. Well, in this case, it's actually just, uh, well, in this case, there's no solution because we get negative 3 equals 1, which means there's no solution. Sorry, I should have looked at that before because these are parallel lines. Parallel lines. So if we just look at this, 2x plus 3 is equal to y, and we take this and we move that y over and that thing over, you would get 2x minus 1 equals y. They are practically the same. So I want to go through another one. Well, I want to keep that example up anyways, just so you guys can see that if you guys get weird answers, then they're probably parallel. Because there's no solution, there's no intercept, which means you would get an illogical answer. So let's have a look at this answer here. This question here. Find the intercept between 2x plus 3 equals y and x plus 2y equals 4. Same thing, we're just going to put this y or whatever this is inside of our y over here. So we'll get x plus 2 to x plus 3 because we've just replaced y. We literally took y out. We put it in with this is equal to 4. So then we'll get x plus 4x plus 6 equals 4. So then 5x is just equal to negative 2. X is equal to negative 2 over 5. So just to break down what I've just done, I simply expanded this, which gave me 4x plus 6. I collected like terms, x plus 4x gives me 5x, moved that 6 over, which gives me a negative 2, and then divided by 5 to get x is equal to negative 2 over 5. We're not done yet, because we still need to find out what y is. If we recall, we know that 2x plus 3 is equal to y. So we can sub that in and say 2, so I'm going to write this out so you guys can understand better, but we're going to sub x equals negative 2 over 5 into 2x plus 3 equals y. And that gives us 2, negative 2 over 5 plus 3 is equal to y. So that's just negative 4 over 5 plus 3, which is equal to, what is that? 11 over 5, which is equal to y. And that is our answer. Well, almost. Our answer is actually negative 2 over 5, 11 over 5, which is the coordinate of intercept. That's where they intercept. Intercept. Ta-da! Alright, I'm going to give you guys a question, and hopefully you guys get it. Honestly, if you know, sorry, the question is find the intercept between negative 2x plus 7y and x plus 2 over y is equal to 1. I was going to say, honestly, if you know how to do simultaneous equations, it's exactly the same. It's just that you're going to be expressing it with the coordinates later. This one's a little bit harder. I'll give you guys a shot at it. A little hint is maybe you can transpose some of these to, sub in later, or maybe you could eliminate some variables. Probably transposing and substituting would be the better option, just to put that out there. Oh, whoops, I've got to make this equal to something. Equal 1. There you go. But yeah, have fun, and I'll see you guys in a minute. Please pause the video and try the question. Alright, welcome back. Let's go through this question together. So I'm going to recognize that I can multiply this by y to turn this into x plus 2 is equal to y. Then I can sub this in to here, there, and then I can say negative 2x plus 7 x plus 2, because that's what y is equal to right here, is equal to 1. And we can effectively solve for x. So I'll give us negative 2x plus 7x plus 14 equals 1, which gives us 5x is equal to negative 13. So then x is equal to negative 13 over 5. Just to explain my maths a little bit, what I did here was, all I did was I subbed in y for x plus 2. We expanded that, and that gave us 7x plus 14. Collecting like terms, negative 2x and 7x gives us 5x, and moving that 14 over, 1 minus 14 gives us negative 13. Dividing by 5, you would get negative 13 over 5, and that would be the x coordinate, but we're not done yet. We still need to find what the y coordinate is. And we know that since since x is equal to negative 13 over 5, that looks sort of like a b, but we can use that, sub that into this equation here, x plus 2 is equal to y, and then find out what y is. So we're just going to put that inside, so that'll be negative 13 over 5 plus 2 is equal to y. So then you get, therefore, y is equal to negative 3 over 5. So then you get the coordinate negative 13 over 5, negative 3 over 5. And just to check my maths, yep, if you combine the fractions, yep, that would be right. All right, sweet. Well, you guys have done the intercepts now. We're going to be moving on to our next topic. So now let's talk about families of linear functions. Families of linear functions. And this is important to know because it's going to come up in application when you're working through problems, especially for JMSS. For the families of linear functions, we'll be looking at three different main cases where we can have one unique solution. We can have no solutions, and then we can have infinite solutions. And what I'm referring to here is a unique solution is when you have one intercept. So that's when the gradients are different and you have one intercept, only one intercept. This occurs when your gradients differ. They have to differ. Now, so they have to differ, and that's about it. So for the next one, for no solutions, it's when our gradients are exactly the same, so that they're parallel. But the only condition is that since they're parallel, so they have to be parallel, which means they have the same gradient, but they can't have the same y-intercept. Because if they have the same y-intercept, then they're exactly the same line. If you have the same gradient and the same y-intercept, you have the same line. So that's just two lines. And then you get m1 is equal to m2 and c1 is equal to c2, which means there is only one solution if the gradients are different. There is no solutions, which means they're parallel, if the gradients are equal, but they don't have the same intercept. And for infinite solutions, if they're exactly the same line, then you have m1 is equal to m2 and c1 is equal to c2, which means the gradients are the same and the intercepts are also the same. So now we're going to look at an example question. Now these don't typically show up at JMSS, but I feel like it's important to know how they work anyways, which will be what I'll be covering next. So this is a bit of a challenge one. Find the values of m such that the following equations have no solutions. Y is equal to m minus 1, x plus 2, and y plus 3 over m minus 1 is equal to x m minus 1. So in this case, we want to put everything into the form of y equals mx plus c. In this case, this is already in the form y equals mx plus c. We know what c is. This is going to be our c1. This is going to be our m1. For the other equation, if we were to multiply by m minus 1, we would get that, it's going to do this on this side, that y plus 3 is equal to x m minus 1 squared. And if you were to subtract 3, you would get y is equal to x m minus 1 squared minus 3, which means that our m2 is going to be m minus 1 squared. I know it's a bit weird, I should have not used m, but just for the sake of this, I'm going to keep going. That's going to be our c2. Now, we know that our m1 and our m2 have to equal, but our c1 and our c2 cannot equal. In this case, we can already see that our c1 and c2 in fact do not equal because we have 2 and negative 3. We don't have to worry about that. We just need to make sure that m1 and m2 have to equal. Now, it also can be noted that this following pair of equations can never have infinite solutions because their c's will never equal. 2 and negative 3 are fundamentally different terms. If we had m on 2 or m on negative 3, for example, then we could make it work. But in this case, it is impossible for this to be it is impossible for there to be a value of m such that there's infinite solutions. So that means the same line. But in this case, we're looking for the pair of equations that have the values of m such that it has no solutions, so that they're parallel. So we can just say that, therefore, since m1 needs to be equal to m2, we can say that m minus 1 is equal to m minus 1 squared, and we can find the values of it that way. So in this case, if you were to expand this, you would get m minus 1 is equal to m squared minus 2m plus 1. And moving everything over to one side, we get 0 is equal to m squared minus 3m, and then that would just be plus 2. And then from factorizing, from what we know from factorizing, now, I know this is coordinate geometry, and you guys haven't really done factorizing, so don't worry too much about this step. Hopefully you guys have done some coordinate geometry, some quadratics. If you're not too sure, please ask your tutor for this JMSS course. And that'll just be m minus 2 and then m minus 1. So then you would get, therefore, using null factor law with null factor law. Again, if you don't know what the null factor law is, ask your tutor. This is going to be m is equal to 2 and m is equal to 1. I probably shouldn't have chosen such an equation that requires quadratics, but that's okay. Hopefully you guys understand. So now I'm gonna get you guys to try one for yourself. I'll make it a little bit easier for you guys, so give this one a shot. Find the values of m such that the system has infinitely many solutions. Y is equal to m minus 1 brackets x plus 2, y is equal to 2mx minus x plus m. So definitely something a little bit different, has different challenges compared to the last one. And obviously it's already transposed for you guys, so hopefully you guys figure that out, and I wish you all the best. Please pause the video, give this one a shot, and we'll see you in now. So welcome back, guys. Let's continue through this. In this case here, this is already in y equals mx plus c. We can see that this is going to be m1, and this here is going to be c1. Now, if we were to factorize out x from this one, you would get that you would have x to m minus 1 plus m. If you don't know how to factorize, again, talk to your tutor for this. Now, knowing this, we can say that this here is going to be our m2, and this is going to be our c2. Now, we know that m1 m1 has to equal to m2. So then we get m minus 1 is equal to 2m minus 1, which means we get negative m, if we move the m's over, is equal to, 0. So m is equal to 0. Sorry, I just had to catch myself there, just checking my maths. I guess I just chose this type of equation. Now, in this case, we know that C1 cannot equal to C2. So then we get that 2 cannot equal to m. So in order for this to be, in order for this to have infinite many solutions, then we would say, therefore, m has to equal to 0 and cannot equal to, and m cannot equal to 2. And that is it. Hopefully you guys got that, and I'll see you guys in the next one. Also, before I go, the next video is going to be about angles. So it'll be the last video in this coordinate geometry section, and we'll be looking at how angles work in coordinate geometry, like between the x-axis and the actual line, and between lines itself.